Hello everyone and welcome back to the course. In today's lesson, we're going to keep on working on sinusoidal functions, but in this case, we're going to do it in the context of data. The following table, time versus angle, represents the oscillation of a metronome's pendulum, where h of t is in radians. Minus 0.5 rad means that the pendulum is farthest to the left of the vertical center line, and 0.5 rad means that the pendulum is farthest to the right of the vertical center line of the metronomes. Now, h of t describes a sinusoidal function if we see it in the following way, using the graph of a function. Now, by checking at that graph, we can notice that the midline is equal to 0 because it represents the average between the maxima and the minima. Now, the amplitude, the distance from the midline to either the maxima or minima, is equal to 0.5. Now, we know by checking at the graph, or even better, by checking at the table, that the period of this sinusoidal function is equal 4. Thus, the value of b is equal to 2 pi over 4, which is equal to pi over 2. Finally, if we remember the shape of the function sine, we know that the function sine starts at x equals 0 and it starts increasing and decreasing again, forming a concave down shape, something that happens at x equal 1 for our specific case. Thus, the value of c, the horizontal shift, must be equal to -1. Therefore, we have that our sinusoidal function must be f of x equal 0.5 times sine of pi over 2 times x minus 1 plus 0, which is the value of the midline. So we can omit such a value and the function f of x will be 0.5 times sine of pi over 2 times x minus 1. Well guys, that's it for today. Thank you very much for putting a lot of effort into this particular lesson. Now it is your time to put your knowledge into practice by solving the following problem. Consider such a chart and try to deduce the form of the sinusoidal function associated to it. Try to find it in terms of sine and cosine. And as always, see you in the next lesson.